Number 7. The inner diameter of a circular well is 3.5 meter. They've given us a diameter, right? It is 10 meter in, it is 10 meter deep, right? Which means this will give us the height of the well, right? So find its inner curved surface area, the cost of plastering this curved surface area at the rupees 40 per meter square. So first things first, they've given us a diameter, right? 3.5. But in place of writing in 3.5, I'll write it simply as 7 by 2. When you divide 7 by 2, you'll get back 3.5, alright? We're doing this just to make our calculations easier, right? So now diameter is 7 by 2. Let's try to find the radius. Radius is half times, right? D by 2. But you know D is how much? D is 7 by 2. So you can see 7 by 2, right? And remember, radius is half times, right? So this 2 is there, which is here, alright? So I'm going to get how much? 2 2s are 4, right? So my radius is going to be now 7 by 4. And like I said, the depth will become the height. All right, now first let's find the inner curved surface area of this well. Inner curved surface area means this. All right, I have to find the surface area, right? So what is the formula? 2 times pi r h. We know the value of pi is 22 by 7. Radius we already got 7 by 4, and height is 10 meter. So I can divide this 7 7. 2 ones are 2 2, then 2 ones are 2 11, right? So 11 into 10, I'm going to get 110 meter square. So we now know the inner curved surface area. The second part is what? The cost of plastering this curved surface area at the rate of rupees 40 per meter square. But how many meter square do we have? We have 110 meter square, right? So the question told us the cost of plastering per meter square is how much? 40, right? But how much meter square do we have? 110. So I just have to multiply these two, and the total amount is going to come out to be rupees 4,400. Alright, in a hot water heating system, there's a cylindrical pipe. Alright, there's a cylindrical pipe of length 28 meter and diameter 5 centimeter. Find the total radiating surface in the system. So this is a pipe, right? And remember that this pipe is not closed. Alright, the top and the bottom are open. That means what? When they ask us to find the total radiating surface, it has to be the curved surface area. Clear? So they've given us a length 28 meter, right, which will become the height, right? So height equals 28 meter, and when you look at the diameter is in terms of centimeter, right? So let us convert it into meter. That means diameter 5 centimeter. If I convert it, divide by 100. All right, now I know the diameter. Let's find the radius. What is the formula for radius? Diameter by 2. So diameter is 5 by 100, right? So you can see 5 by 100, and this 2 is here, right? So I'm going to get 5 by 200, which will be my radius. Now the total radiating surface, like I said, it will be the curved surface area of this pipe, right? So 2 times pi r h. Pi is 22 by 7, radius is 5 by 200, and then h is 28. Once we put all the value, let's start dividing. 7 1 is 7, 7 4s are 28, 2 1s are 2 into 100, then 5 1s are 5, 5 2s are 10, right? Then 2 into 11, and 2 10s are 20, which means I'm having what? 11 into 44 is 11 into 4 is 44, and then this 10 is there, right? 10. So if I divide, I'm going to get the total radiating surface to be 4.4 meter square, which will be our